Hey, welcome back to part two. All right, so we're going to talk like inside a PCM now. And hopefully you got this when you were taking like the original ones. And I have another video about, computer switching. You can go watch that one if you'd like. But there generally are two different types of computer switching that they do. One applies a voltage out of the PCM or uses straight signal voltage. And then coming up, come on, where'd my little arrow go? So I send 5 volts out here, and when the switch is closed, this line turns to 5 volts. Now there's this dropping resistor that goes across here, and the reason why that's there is because when the switch is open, we can get a lot of extraneous voltage on this line, and this resistor pulls it back to ground, so it's 0 volts when the switch is open, and it doesn't get any sporadic voltages in it. Then we also have what's called a pull down. Here's a pull down. So again, same dropping resistor they have on it, and we apply 5 volts through it, and then when the switch goes to ground, it pulls this line to 0. And when the switch is open, it pulls back up to 5 volts or whatever this reference, this VREF is. Okay. Temperature sensors. So if we look at it, this is a common graph that's used on these temperature sensors. So it starts out at, it's a 5 volt reference on this guy, and it has some resistance built into it, and then as it heats up, as the temperature goes up, the resistance increases, and that pulls this voltage down. Now, I know this is a 5 volt reference device, but the highest voltage that it goes to is 4.3 volts, and the lowest it goes to is about 0.1, 0.2. It'll never, ever go all the way to its reference voltage, and it'll never pull it all the way down to 0. Why? Because the computer would then know, since it's not designed to do that, if it sees 0 voltage or it sees 5 volts, the computer knows there's a problem. If this is hooked up to the PCM, this is where your check engine light comes on. Loop. Sets a code. Okay. So inside the computer, this is how it looks on like CTS, coolant temperature sensor. We have 5 volt reference coming out. This is on GM. This is a yellow line. And then the ground is actually fed back in through the computer again, so that the computer can actually monitor this ground and tell what kind of condition it's in. And then here's where the signal voltage is taken. Get it? So as this resistor changes, as this thermistor changes resistance, this voltage varies. Get it? No. So if I unplug this sensor, like I disconnect it, this line, this signal voltage line right here, will go straight to 5 volts. Oh, that's the problem. Or if I short this line to ground right here, what happens to the voltage back here? It goes to 0 volts. That alerts the computer that there's a problem. Get it? All right. So one of the things I look at is if I'm dealing with an ECT, an engine coolant temperature sensor, if the car's been cold soaked for a while and it's been sitting there for a while, I want to check and make sure that it's actually reading the right temperature. And the easiest way to do that is when it's cold and it's sitting there and it's been there for a while, ECT should be about the same, plus or minus a couple of degrees, 6, 5, 3 degrees difference between the IAT, and that's the intake air charge temperature. So ECT and IAT should be the same, key on, engine off, or KEO. Most, now I'm picking on GM. I apologize. I don't mean anything bad by it, but they've gone, and this was years ago, and most manufacturers are doing this now, they've gone to what's called a stepped resistor, a stepped ECT. And what that means is on this, here is my 5 volt reference, but if you notice there are 2 resistors in here, and it actually changes, it's like a 2-speed, it's like second gear, okay? So if you look, as this guy starts to heat up, the voltage drops, and then all of a sudden it jumps back up high again, and then it drops down again. This happens at about 160 degrees. We okay? Are you all right with this? Now, why did they do this? Well, virtually everybody's done this, and here's the reason why. This is a generic logging form from, what the heck was it, 2001 Jeep Wrangler. And I'm monitoring the voltage of the ECT, and as you can see, it's, heating up, heating up, heating up, and then you see these humps right here. Well, what are these humps? Those humps are the thermostat opening and closing. So new cars, they use this to monitor that the thermostat is open and closed, because new tier 2 stuff around 2004, it has a monitor for the thermostat. This is how it works. Okay. Variable resistor is used most often in these sending units, and they're really pretty easy to diagnose. All I got to do is just figure out exactly what resistance it's supposed to be, and then I can go measure it. How much gasoline is in the tank. And then what I can also do is I can input in a different resistance, and I'll show you that when we get into the lab. Okay. Modern day gauges are the same. They still have an analog input, generally some type of a sliding resistance, changing resistance that pulls down some type of a reference voltage. But they're controlled by the body controller, the engine control module, or the IPC. And the gauges are no longer moved by a horseshoe magnet or coils. Generally, they're moved by a stepper motor nowadays. Stepper motors are pretty simple. Unlike a regular motor, when I hit a regular motor with current, power, and ground, it spins until I remove the current. With a stepper motor, it's a little different. I hit that with a current, the shaft of the motor turns one step. Take the power off, hit it again, it'll move one more step. It doesn't go all the way around. Some of these guys are 4,000 count, which means it takes 4,000 pulses to get it to make one turn. That's a stepper motor. Okay. Speedometers. Whoa, speedometers. In the olden days, they were cable driven. So they had this cable that came off the transmission that spun, kind of like a bike brake cable. It spun, and there was a magnet in a cup. And the magnetic lines of force of this guy spinning right here would drag this cup along, and it'd overcome this hairspring and pull the needle over. Now, we don't do that anymore. Okay? Anyways, we don't do that anymore. Modern day speedometers are using vehicle speed sensors. Usually they could be in the trans, they could be an output shaft, or they could be in, like BMWs, they put them in the rear pumpkin, or some of the more modern vehicles are using ABS wheel speed sensors to monitor vehicle speed. So what's monitoring vehicle speed? Usually it's just a simple 2 or 3 wire sensor that sends these pulse signals back to the BCM, ECM, IPC, or some computer that gets decoded, and then they put it up on the network for anybody that needs it. So what causes these things to malfunction? Sometimes larger or smaller tires. A lot of times this can be calibrated in a scan tool for larger or smaller tires. Sometimes it can't, and it just throws your speedometer off. That's about it. Through gauges. Yay.